Timber Talks is brought to you by Wood Solutions. Stay up to date with the latest in timber, the building material that is strong, safe and sustainable. Here is your host, Adam Jones.
One of the advantages of timber is its ability to enable prefabrication for a building to simultaneously improve the quality, price and program for a project. But the design, logistics and manufacturing, they're all critical for efficient offsite construction, and you need to get these right to achieve these productivity gains. At the Frame Australia 2019 conference, I got to speak with three world-leading experts on this topic. In this episode, you're going to hear from Nick Hewson, the design manager for Xlam, on design for manufacture and assembly and logistics. Second, you'll hear from Karel Vinckier, who is the founder of HSBCAD, on the evolution of BIM. And then finally, you'll hear from Skoglund, the COO of Randek, on the advancements in robotics. So I learnt a lot from these three gentlemen. I'm sure you will too. So without any further ado, we'll get into the podcast interviews. First off, we have Nick Hewson from Xlam. In terms of design for manufacturing and assembly, what do you think are some of the most important things that designers should know so they can help as much as they can for efficient offsite manufacturing?
Yeah, thanks, Alex. It's a good question. I think it's a different way of thinking about building from what most designers are used to. You know, we're used to kind of building from the material up, but this is a product that we're working with. So you're dealing with a kit of parts, and I think that's a sort of fundamental understanding that a lot of designers are kind of struggling with at the moment. You have to be able to understand that whole process, and that's right the way from log through to things arriving on site, things getting installed, to really kind of designing the real efficiencies of the system. So, what I say to designers is please come visit, go to see the manufacturers, go to see their facilities. I said you'll learn more in 2 hours there than you will in 2 weeks of reading books and going to seminars, because you actually get to live it, experience it, and you can see very, very quickly where the way you're designing is having a huge impact, because it's not just about material volumes at the end of the day. It's how long does it take to cut, how long does it take to handle. That's one of the learnings from our factory is just the sheer amount of handling that goes on. So if we want to make the most efficiency out of the system, we want to build panels as large as possible. What really slows us down is cutting it small into tabletop size pieces and building a building that way. There are much more effective ways to build if you want to do it that small scale. Yeah, well, I think what a lot of people probably don't realise is, we're all talking about BIM, and it's the saviour of the construction industry. But what we find is a lot of people will talk about it, but a lot of people kind of aren't able to follow through. So, if we're manufacturing to millimetre tolerances, then, we need a model that's done to millimetre tolerances, and we throw out 80% probably of models that we get through. So they're just not built accurately enough. We'd spend more time trying to correct all the errors in it than it often becomes easier just to build it from the ground up ourselves, and that's enormously wasteful. Double handling is crazy. So what we want to either, if the design team want to take that on themselves, it's about understanding how accurately they need to build it early on, or the other alternative that we're doing now on a lot of projects is to get involved early. So that might be to kind of own the timber portion of the model from day one. So we use that as the skeleton that gets passed to the architect, engineer, everyone, and they build around that. But we own that timber part. So that means that we can be setting up the model in such a way that it's much more seamless flow. That can do things. It can reduce lead times. It reduces errors, and I think that's hugely beneficial on the projects that we have worked it on. And the other benefit, I guess, of having us involved early is that we get to advise on some of that. The DFMA. The biggest challenge we have is if we've never seen a project before and then it comes in a tender and you sort of win it, and then you've got to start delivering panels in 12 weeks. There's no room there to redesign, to try to make things more efficient. You have to kind of deal with the hand that you're dealt. But at least if we're if they've engaged with the suppliers early, then they can be providing that input and saying, there are better ways to do this detail. You can do this. This will cost you more in the factory, but it may have other savings on site. So where's that balance? Where does that pendulum swing? Where do you want to kind of put in the cost? Where do you want to save the time?
When it comes to logistics as well, and what's your role as the supplier with logistics, from an Xlam point of view, being able to supply in Australia, and then maybe what it might be as well for an overseas supplier?
I think logistics is absolutely critical to this, because we're all sitting around talking about the benefits of timber, and one of the big ones is being the benefits of speed. So if you are having to double handle, if you are having to take panels off on site and unstack them to pick the right one you want for the next sequence, then you've lost all benefits you have in terms of speed very, very quickly. So something that we do at Xlam is we work very, very closely with the builder, with the installer early on to say, right, what order are we going to build this in? And we help that. We have a team of project managers and a very experienced team of draftsmen to help try to get everything on the panel, everything on the truck in the right order. We sequence that with, what size truck you can get to site, what time of day do they want delivered. So we have holding yards in Melbourne, Sydney, Adelaide to be able to kind of get stuff there, when people are on site at 7 a.m. in the morning. But the challenge for designers will be that Xlam are an option in Australia. We can probably deliver bigger panels than some of the Europeans can, but designing the systems in such a way that they make they can be one or the other. They could be onshore, they could be offshore. Understanding restrictions around shipping containers, different ways of transporting materials have some benefits. They all have costs. There are potential risks around damage, particularly when you're kind of going break bulk and trying to lift bigger panels. But that all needs to kind of be thrown into the mix when you're kind of considering your supplier and your project.
So Karel Vinckier, you started HSBCAD a while ago now. What prompted you to start this software, and how have you seen the building information modeling evolve since then?
It's like I said before in the meeting, and I had my own company to do design work. To design the construction, I got a drawing from the architect, and the company asked me to translate this drawing into the things you need for production. At the time, I'm talking about 88, 89, everything was done by pencil and paper. And what you see quite quickly is that the only thing that stays the same are the changes. So they're coming back, can you move this window, can you change the pitch of the roof, etc. You have to redraw. Then, if I look back in my past, I was very lucky that my father bought the first Apple II computer in Belgium for us. So at a young age, 14, 15, I started to play around with the computer, and it was kind of natural. So when I was encountering that kind of work that I have to do, that I have to redo all my drawings all the time, I started to generate a little software that I could do it in an automated way. That's in effect how it started. And then after a time doing a lot of that kind of work for multiple customers, and one of the customers came to me and said, well, we are using AutoCAD. Can we have your product based on AutoCAD? So that was a new challenge, and that's how I started to migrate the software that I developed into a package that was on top of AutoCAD. So I was very, very lucky that AutoCAD became the CAD leader worldwide. So, and at that time, of course, you see that there is a need for speed, there is a need for being able to cope with all those changes, and in an automated way with software, I would say it was natural, that was the way forward. And that's in effect how I started to develop out of that kind of experience a package that could that could deal with the needs of those companies and get digitized.
Amazing. So can you talk through the high level of the workflow from the engineer through to construction and where HSBCAD fits in there and helps with this process?
Yeah. So HSBCAD is, in effect, what I always say is, we start where the architect stops. So we are not interested in designing a nice picture. That's something for the architect. At that moment, and I'm talking more about how it goes and how the industry works in Belgium, that's where we started, of course, is the architect is drawing the model, the house, but at that time they don't know who is going to build it. So you don't know the details, you don't know the restrictions. Even at that moment, the customer can say to the architect, yes, I want to have it in brick, I want to have it in concrete, or I want to go to, in that time, a new system to go in wood. So you don't know what it is. So the architect is just designing in a generic way. And then you have at that moment, they are going to choose a way how it is going to be built, what kind of materials, and they are going to choose a factory. And in effect, only at that time, our software will kick in. So if that company is doing stick framing and they have our software, they get the design of the architect, and then they have to mostly redraw it and using the drawing from the architect as a kind of template, adjust it to the basic things. Let's say the architect is going to draw the walls at a thickness of 12 centimeters, for example. The stick framer, the walls is going to be 15 centimeters, something else. So you have to redraw the whole drawing in 3D using the drawing from the architect as a template. And so that's the moment where we kick in. Then you're going to redraw it. At that time also mostly the engineering, if needed, is already done. So they know already what kind of sections they have to use, the experience of the building company. And that, so our tool is at that time just a design tool. We are not going to take into account what is possible, structural or whatever. We are taking into account how the production company is producing the houses, what restrictions do they have, maximum wall length, all kind of restrictions you can have due to the production. And then we generate all the data needed for prefabrication. So the first stage is in effect just to get all the shop drawings, the bill of material, and in case, and that's getting more and more, in case those companies has a CNC machine, let's say just a machine cutting the pieces of wood, and we generate all the data for this kind of machinery. That's, I would say, this is really core basic HSBCAD stuff, what we have been doing for, let's say, for 20 years.
And when it comes to the manufacturing part, how does, I think it's HSB production controller, how does that assist with the efficiency inside the factory?
So the production controller has been renamed to HSB Make. And so what it does is, in effect, it takes, you have all the data of the houses you want to produce in detail, and position of the beams, position of the nailing, what has to be milled and drilled, etc. And then you have to produce all those elements. And it's not like in the car industry where you have just one line where everything passes linear through the factory. In our case, it is kind of random, depending if you have the amount of layers of seating that you have, and if there is an opening, yes or no, it first has those openings has to be made on another table. So it's more complex, and you have to imagine, if you don't have a software system, you're walking around with a bunch of paper, looking which element is now on my table, which sheeting corresponds to this panel, and you have to sift through all your paper and find the right one, etc. There is a lot of room for error. If you do it manually, you can adapt quite easy. But if you have a CNC machine and you put on the wrong file on the machine that's going to do the drilling on the milling and the nailing, you're going to have awkward results. So there is definitely a need to have a coordinated system that will take care of that. And our first client in the States, in the UK, was Space4, who wanted to have that system together with the machinery of Weinmann. They have about 30 CNC machinery and a lot of manual job places. And for that we developed that kind of software. And since 2001, they're using that. So the whole factory is coordinated by the HSB make. There's no room for error, and it just runs fluently. They are producing one house an hour, and we didn't have any issue till today with that.
Yeah. So what do you see as some of the potential of other technologies not being fully utilised at the moment? Things like AR and VR in this whole process.
Yeah, for us, and that's a little bit in the genes of HSBCAD, we have a sandbox mentality. We like to look at all kind of new technologies popping up, and then we let everybody think and imagine what could be possible with this kind of technology. How could we implement that? Yeah, and I hope once to find the holy grail that everybody's going to say it's not nice to have, but it's a must to have. Yeah, that's the challenge. And that's how we started with the HoloLens as well. We got one of the first HoloLenses that we could buy from the States, and we started to play around with it and see what's possible and imagine how can it be used in the factory, how can it be used on site. And we let our people play around with it and imagine kind of tools. And then, like you have seen yesterday, we had a nice example where you can superimpose the 3D drawing on top of a real element and added value to that and see what the people has to do. But it's in its infancy. And we are thinking out of the box, I would say.
So we've already spoken to Nick Hewson and Karel Vinckier. Now, Ulla Skoglund, you are the COO of Randek. You're an expert in robotics. From your perspective, how can we achieve really efficient manufacturing?
Yeah, efficient manufacturing within a factory consists of a lot of things to make it efficient, as you say. Everything from starting with the drawings or the BIM data, getting that right and optimized for the actual work in the factory, and also setting up the machines right to accommodate the BIM data. A lot of work goes into factory layouts, of course, and logistics and flow, and all these things need to come together to optimize the flow of the factory to make it really efficient. One way of doing that is by using robotics or industrial robotics as we do it, and it has some advantages to conventional machines, but there's room for both sorts, I think, still in the industry. But it's the pre-work that needs to be done together with the supplier and the integrator and the customers.
How does the robotics help with productivity within the factory, and what kind of tasks are they taking away from what used to be there and maybe humans were actually involved with?
Well, they help in a lot of ways, but mainly they're good at doing repetitive tasks, of course, and they're good at being flexible, since they have so many axes and they're a trusted, reliable system since it comes out of the automotive industry. So what we've been focusing on to begin with is mainly like sheet laying. That's a rough task for a human to perform day in and day out, since often you have the sheets behind you and you have to rotate your upper body to accommodate placing them on, like with a vacuum lift. Also screwing and nailing and stuff creates a toll on your body, and it's also a risk, of course. I think the industry has a lot of accidents with nail guns and so forth. And also routing and scrap handling. So that's essentially what the zero labor system does today. But that's just the start of it. But yeah.
We're at Frame Australia at the moment, and yesterday you had a presentation where you had a video of your zero labour system. And I think that's, if I look at a photo or a video of what Tesla is doing in the automotive industry, it looks like they've got a lot of these robotic arms doing a lot of the automation. And this is the first time that I've seen something similar in construction. So can you tell us about what the zero labour system really does in maybe a step-by-step kind of process?
Yeah, it works in a similar way. If you're accustomed to seeing these automotive lines on TV, it sure looks similar, and it is in a way. What it does, it's based upon robotic cells. So depending on the layout or the complexity of the walls, the completion level on the walls, if you're doing closed walls or open walls or sheeted or non-sheeted, the setup will be a bit different from case to case. But it actually works a little bit like, you say, in automotive industry when you have a running belt. Yeah. So the wall comes in, and the robots do the work assigned to it. The data transfers into the robot cell, and it does the work that's assigned to the wall, and send it to the next cell. So it could be routing, sheet placing, nailing, screwing, ink marking, gluing, and that's the nice thing about the robots. There's really no boundaries. You can do a lot of things, and since they're so flexible with all these different axes that's available, we can evolve it as we go, and so can the customer, really.
Say the cost of a physical arm, is most of the cost in the actual physical material in creating the arm, or is it actually in the software, the algorithms that's created for the robot? The reason I ask is because, you know, I'd imagine it might be cheaper in future if all the cost has been in generating the really smart algorithms, and that can be applied to a lot more, robotic arms.
Well, I think it's a balance. I mean, of course, the arms are not they don't come for free, but there's a lot of technology going into it, both in the arms and all the stuff that goes around it, the support systems and also the electrics. There's a lot of time behind the coding for sure, and that's what I touched base with yesterday on my presentation, comparing it yet again to the automotive industry, where in the car line you have the robots are more hard coded, you could say. They're doing tasks that's predefined, programs that's predefined and optimized in a different way that we can do it. We have to read every drawing and interpret the drawing and assign data and create programs as we go. So we are actually more flexible in that way than the automotive industry. So we need to, if we didn't, I mean, there's not a lot of house builders who will say that I have only 2 modules with 4 walls, so you can do just special programs for this and nothing else. No one wants to do that. Everyone wants to just be able to send a drawing in, so that's a very important part of it. I think in the future you will see more and more workers becoming operators, and I think that's a good thing. I mean, when I started out my work in my career, like over 20 years ago, I was a bit skeptical about doing automation because I thought that maybe this isn't a good work to have. I will take jobs from people, and I really had to think about it, but it hasn't turned out that way. Often we just come in with automation and it generally boosts the customer, so actually they hire more people because their revenue go up and they can do more things, and it's all about removing the jobs that are not good for people anyway. So it's a balance, but people have soft values that robots can't do. I mean, the body and the human is a complex thing, so there will be room for both, for sure, even in the future when things get more collaborative. But I think that empowering people by making them operators is a way to get people back in the industry and get we need to excite the young kids. They want to see the cool technology. So that, like I said yesterday, not everyone wants to do apps or be a YouTube star.
That's right.
Yeah.
Yeah.
I think in the near future we will see a lot more tasks being done by robotics, but in a factory environment. That's kind of my message also now, that companies like ours need to focus on putting robots into the factories where they can operate at the maximum efficiency and give the return of investments to the investors. But I think also, like I said yesterday, what the universities are doing and some other companies are doing, but looking at robotics at work sites is also very important, because I think it'll be an important part of the future. So that's probably in 10, 20 years' time we will see more robots on site. But I think that when it comes to manufacturing in a factory, it's hard to beat the efficiency and the quality and the support systems that you can have in a controlled environment like the factory. So I think there will be place for both, surely.
If you got a question about wood, I recommend you check out the Wood Solutions website. It's the world's biggest website on wood, and on it you'll find the technical design guides. So right now there's 48 of them, with that number growing all the time, where we get Australia's leading experts really going deep and detailed in a range of different topics. So if you've got a question, or if you want to just upskill yourself in timber design, then go and check it out.